Hi, I'm an old guy and I do maths, and I think that for some people this looks pretty scary. We've got lots of things here to put off people. We have 9 raised to quite a difficult power. We have 2 raised to the power of 27. That's a serious number. And what we're going to try and do is we're going to try and simplify this as much as we can without resorting to a calculator. I think in the end I might do one part of this on a calculator just to show you what it is in its expanded form, but we'll come to that. We'll see what we get. Okay, so we have a fraction here, and each part of that fraction is raised to a different power. And outside here we have what's called a fractional index. And the important thing to note about a fractional index is that obviously it's got 2 parts. Now, each one of these parts does a different job, and it's possible to do those jobs one at a time. Now, this number up here, so I'll just write this like this so that it's easier to see. This power up here, this number up here, I gave the game away, is what I like to refer to as a power. It is, if we didn't have this here, it would be something to the power of 2. This number down here is the root. And if we didn't have 2 there, say we just had 1 there, or we expressed this a different way, such as that, it would be the 9th root. So, power, root. And we can use the fact that these do different things to make this a great deal simpler for ourselves. And so the first thing we're going to do is we're not going to make this any worse. We're not going to raise this to the power of 36 or this to the power of 54 by multiplying by 2, which is what we do when we have an index. So if we go 5 to the power of 3, and that is, say, 5 to the power of 2. So 5 to the power of 2 to the power of 3 would be 5 to the power of 6. We would multiply those. Let's not get into any more trouble. Let's not raise this to, what did I say, 36? And that to 54. I hope that's what I said about that. Okay, what we're going to do is we're going to use this part of it, and we're going to make these numbers smaller. So just as we would multiply by this, we can effectively divide using this. And so we will get 18 divided by 9 is 9 to the power of 2. And 27 divided by 9 is 2 to the power of 3. Now, we still have the 2 out here. The 9 is gone. We'll just put a line through that, across through that, so that you can see what's going on. The 9 is gone. So, we apply our next rule, which is having used this to divide these numbers and make them considerably smaller and more manageable, we multiply. So this becomes 9 to the power of 4. That might be what we need a calculator for if we're not prepared to leave it in that form, over 2 to the power of 6. And that, I think, is a reasonable answer for this. What we can do from here, if we want to, is we can work out what 9 to the power of 4 is. So I'll just do that. It wasn't particularly my intention. I think that's a suitable answer. But if you are pushed into a tight space and you have to figure it out, it is 6561 over 2 to the power of 6. which I think is 64 from memory, but I will check that as I'm recording. So 2 to the power of 6 is 64. This is not going to simplify easily, if indeed it does simplify, and it's maybe an object lesson about leaving these in a form in which they look simple. I would leave the answer like this. I'm not going to bother trying to simplify this. As I said, it won't simplify easy because that's an even number and that's not. So I can't play the old trick with just dividing by 2 and seeing what I get. So I'm going to leave the answer like that, 9 to the power of 4 over 2 to the power of 6. And the purpose of this lesson was not about simplifying that or even expanding this. It was about explaining how we get from here to here. Thank you very much for watching. I hope you found that useful. If you did, please like and subscribe, and I'll see you next time. Bye.